There are electronic boards that use relays to control both the operation and speed of the fan motor. In this context, it is crucial to use a specific relay for each speed. However, more modern electronic boards opt for a different approach. Instead of using multiple relays for each fan speed, they incorporate an electronic control device known as a Triac, which manages all control through a single device. The Triac, in turn, requires an optocoupler for its activation through one of its pins, called compound or gate. This optocoupler is under the influence of the main brain or controller of the electronic board, which communicates with it through one of its pins. When the controller detects the zero crossing of the voltage signal, it accurately counts the milliseconds needed to send the appropriate voltage to the optocoupler during the required activation time. The goal is to achieve a specific speed in the fan motor. When the Triac receives the signal from the optocoupler at its gate pin, it acts as a closed switch. The pins known as M1 and MTS communicate and allow the passage of alternating current to the fan motor. For example, if the required speed in the fan is high, more voltage activation time to the motor is needed. Therefore, when the controller receives the zero crossing signal, it quickly activates the voltage supply to the optocoupler. This, in turn, activates the Triac through its gate to close the current passage switch to the motor. Since the required speed is high in this case, as the Triac was activated quickly, it will take more time to remove the voltage from the optocoupler. This allows the motor to receive more energy, resulting in faster rotation. On the other hand, when a low speed is desired for the motor, the controller waits for the zero crossing of the voltage curve, delays more time without activating the signal to the optocoupler, and in this way, maintains the activation of the voltage from this optocoupler for less time. In this way, the motor receives less energy, resulting in slower rotation. Triac failure. The Triac, located on the electronic board, is a single element responsible for controlling all fan speeds. B. When the Triac has problems, the fan generally does not turn off or does not turn on. C. Locate the Triac, and become familiar with its pins. Generally, the pins are labeled as MT1, MT2, and gate. Use the serial number to identify them. D. Disconnect the fan and the power supply from the electronic board. Set the multimeter to electrical resistance mode. E. Connect, for example, the positive, red, cable of the multimeter to the MT1 terminal of the Triac, and connect the negative, black, cable of the multimeter to the MT2 terminal of the Triac. F. You should measure infinite resistance, because the Triac is not activated, indicating that there is no continuity between MT1 and MT2. G. Move the multimeter probes. Now measure the resistance between the gate terminal and the MT1 terminal. It should show a non-infinite resistance value, because there must be continuity. H. Move the multimeter probes. Now measure the resistance between the gate terminal and the MT2 terminal. It should show an infinite resistance value because there should be